All right, guys, our lesson today is all about multiplying a decimal by a whole number. In this lesson, we'll talk about how to multiply a decimal times a whole number, and we will also review some multiplication strategies I know that you have learned in previous years to help you remember which strategy you like the best. So here we have a whole number, 4, and the decimal 83 hundredths, and we want to multiply those two together. But what do we know about multiplication? We know it is the same as repeated addition. So how about we rewrite this problem as repeated addition? Here we have our multiplication problem, and we know it will be equal to 83 hundredths plus 83 hundredths plus 83 hundredths plus 83 hundredths. We are going to add it 1, 2, 3, 4 times, so it is the exact same. Well, we're pretty good at adding decimals. We know what's the key to adding up a decimal numbers. That's right, you have to line up your decimals and then add the digits in the same place value. So here I've rewritten our 83 hundredths plus 83 hundredths plus 83 hundredths 4 times, lined up my decimal in all my places. And now I can find the answer. Let me just make it a little bigger. There we go. So 3 plus 3 plus 3 plus 3 is, well, this is 6, 9, 12. Carry my 1. And then 8 plus 8 plus 8 plus 8, 16 plus 16 is 32. So that's 33. Carry my 3. And zeros, that's easy. And then don't forget my 3 though. And finally, my decimal goes right where it should. So if you look closely at this answer, you'll notice that there are 2 digits after the decimal in the problem. So there's going to be 2 digits after the decimal in your answer. Here, we've got the 8 and the 3, 2 digits. Here, we've got 1, 2 digits as well. That's the key to remember when you're multiplying a decimal. However many digits are after the decimal in the problem, that's how many digits will be after the decimal in your answer. So if I were to solve 83 hundredths times 4, I would just ignore that decimal. And I know you've been told that before in 5th grade. So 4 times 3 is 12. 8 times 4 is 32 plus 1 is 33. Carry my 3. 4 times 0 plus 3 is 3. Now I see there's 2 digits after the decimal in the problem, so there would be 2 digits after the decimal in the answer. And my answer would be 3 and 32 hundredths. So let's practice some. The key to remember is you'll have the same amount of digits after the decimal in your answer as there are in the problem. So in this one up here, 3 times 14 and 2 tenths. How many digits are after the decimal in the problem? Just 1. It's not right. There we go. Just 1. So that means my answer will also only have 1 digit after the decimal in my answer, okay? Now I'm going to go ahead and multiply these using the standard algorithm. When I multiply numbers like this, I always take the number that has more digits to put on top. So I'm going to put 14 and 2 tenths on top of my problem. And I can do that with multiplication because I think it's called the commutative property. The numbers can move around. 3 times 4 is the same as 4 times 3. So in this case, 3 times 14 and 2 tenths is the same as 14 and 2 tenths times 3. I'm going to ignore that decimal and I'm just going to multiply these. 3 times 2 is 6. 3 times 4 is 12. Carry my 1. 3 times 1 plus 1 is 4. Now, where should I put my decimal so there's only 1 digit after the decimal in my answer? I should put it right here. The 6 is the only digit. That's 1 digit after my decimal, just like in the problem where the 2 was the only digit after my decimal. So the answer to 14 and 2/10 times 3 is 42 and 6/10. All right, let's go over here and try this one. Here we got 4 times 95 hundredths. Once again, how many digits are after my decimal? 1, 2. That means in my answer, there will only be 2 digits after the decimal. Again, I'm going to choose the 0 and 95 hundredths to go on the top of my problem because it has more digits. Now, 4 times 5 is 20, carry my 2. 4 times 9 is 36, plus 2 is 38, carry my 3. 4 times 0 is 0, plus 3 is 3. Now, where should I put my decimals so there's 2 digits after the decimal? Some of you might say, is 0 a digit? Yes, 0 is a digit. So that means I would put it right here. So that way there's 2 digits after my decimal in my problem. In my answer, just like my problem. So I could say that this answer is 3 and 80 hundredths, or when there's a decimal and there's a 0 on the end, you can ignore it. And you could also write it as 3 and 8/10. Either one of these answers would be correct. All right, so I want you to pause the video, write down these 2 problems, and we'll go over them and see if you got them correct. All right, I'm trusting that you paused it. If you haven't, you should do that now, because I'm going to give you the answers, and I want to see if you got the same answer as me. All right, so in this problem, I'm going to put the 0 and 25 hundredths on top, times 5. Ignore the decimal, and 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. And 5 times 0 plus 1 is 1. And you should have put your decimal, there's 2 digits, so you should have put it right here. So 5 times 25 hundredths is equal to 1 and 25 hundredths. All right, this next one, we've got 4 and 47 hundredths times 8. This one has more digits, so I'm putting that one on top. 4 and 47 hundredths times 8. All right, I'm going to ignore the decimal and multiply. 8 times 7 is 56. 8 times 4 is 32, plus 5 is 37. 8 times 4 is 32, plus 3 is 35. Now, you should have put your decimal, there's 2 digits, so you should have put it right here to make sure there's 2 digits after the decimal in your answer. So 8 times 4 and 47 hundredths is equal to 35 and 76 hundredths. Hopefully you got those correct. I forgot to mention, sometimes multiplication can be tricky because we don't know our facts. So on Google Classroom, your math assignment, I added a math tools category, and I put a couple multiplication charts in there for you. But you also have a multiplication chart in your assignment notebook or planner. It's in the back somewhere. I can't remember exactly what page it's on, but it's in there somewhere. So you can use that to help you. I don't want you to use calculators, but you can use your multiplication charts, okay? All right, let's look at the next slide. All right, here we're going to review the different ways that you've learned to multiply. I have been using the standard algorithm, but we could also use the area model. So let's say we have the problem 36 times 19. For the area model, you make a big box, and I always tell my students, the bigger the better. I like big boxes because you can write a lot inside of them. And then this number has 2 digits, so I'm going to split it into two pieces. And this number also has 2 digits, so I'm going to split it into 2 pieces. So 36. I know that 3 is 30, and I know the 6 is just 6. 19. I know the 1 has a value of 10, and the 9 is just 9. So now I'm going to go in and fill in my boxes. To fill in this box, you multiply the number on top and on the side. So what's 30 times 10? Well, I know 3 times 1 is 3, and then I see 2 zeros, so those go on the end. So 30 times 10 is 300. What's 6 times 10? Well, that's easy for me. That's 60. And then for this box, I'm going to multiply 9 times 30, which would be 9 times 3 is 27, and it only has 1 0. And then 6 times 9 is 54. All right, so then what you do is you add all these numbers together to get your final answer. So we'll add 300, 60, make sure you line up your place values, 270, and 54. And I'm adding these up. So this 0, 0, 0, that's 4. That's 13 plus 5 is 18. Carrying my 1, 6. So now I know that 684 is the answer to 36 times 19. Partial product is another strategy you've learned in the past. The way that one works is a little different, but very similar to the area model. You'll see the same numbers. So if I'm going to multiply 36 times 19, I want to show you how we'll get the same answer. I do 9 times 6, that's 54. And then I do 9 times 30 because I know this is in the tens place and it's worth 30. So 9 times 30 is 270. And now I'm going to move on to the 1. But the 1 is actually worth 10. So I'm going to do 10 times 6, that's 60. And then 10 times 30, which is 300. And if you compare these two strategies, look, we got the exact same numbers, and we're going to add them up. This would be a 4, 13, 18, plus carry my 1, and there we go. We got the exact same answer with two different strategies. So I've been using the standard algorithm, which if you're comfortable with that, definitely use that. And that's where you carry numbers, so you don't have as many numbers down to add up. So this is 54, carry my 5. 27 plus 5 is 32. Put down my 0. 1 times 6 is 6. 1 times 3 is 3, plus 5 is 8. Are you kidding me? What did I do wrong? I'm doing something wrong. 1 times 3. Oh, you know what I did? I did something that a lot of students do. When I carried the 5, I used it again when I should have only added it up here. So here I was looking, I knew I did something wrong, but my error analysis is when people carry numbers, sometimes they add it when they're not supposed to add it. So I'm going to start over because I can't erase right now. And 36 times 19, let's try that again since that one was wrong. All right, so 9 times 6 really is 54. 9 times 3 is 27, plus 5. I'm going to mark it off so I don't add it again. So 9 times 3 is 27, plus 5 is 32. Don't forget my 0 because I'm moving to the tens. 1 times 6 is 6, and 1 times 3 is 3. Now I can add this up. This looks much better. 4, 8, I'm running out of room. 6, whoa. Let me extend it so I can show you. Yes, 4, 8, 6. There we go. All 3 different strategies gave me the exact same answer. So you can choose whichever strategy you prefer with multiplication. I know in the past, a lot of students really love this area model. And if you love it, use it. You don't have to do the standard algorithm. You can choose any strategy that works for you, but I don't want you to use your calculators, okay? All right, so let's look at another one. So I'm going to show you how to use the different strategies with decimals like we've been doing. So the area model, I am going to draw a large box. The bigger, the better. And this one has 2 digits, 12, so I'm going to split it in 2. In this one, I can ignore the 0 since it's in the beginning, and I'm going to split it into 3 sections because there's 3 digits. So here we have 10 times 2, and remember you can ignore the decimal, so that 1 should have 2 zeros after it because it has 2 digits after it. The 8 should have 1 0 after it because it has 1 digit after it, and the 3 is just all by itself. So 10 times 100 is 10,000, or 1000. 1,000. I'll get it right, don't worry. 2 times 100 is 200. 10 times 80 is 800. 2 times 80 is 160. 10 times 3 is 30. And 3 times 2 is 6. Now I'm going to add them all up. 1,000, 200, 800, 160, 30, and 6. So here we have a 6, here we have 9, here we have 11, and here we have 2. So I get 2,196. But we're working with a decimal. So how many digits are after the decimal in the problem? 1, 2, 3. So that means I have to put my decimal here because I have to have 1, 2, 3 digits after the decimal in my answer. All right, so let's look at the partial product. Once again, I am going to write the number that has more digits on top. And for this one, I write my answer down under it. I don't do any carrying. So 3 times 2 is 6. 2 times 80 is 160. 2 times 100 is 200. And 2 times 0 is 0, so I'm not writing that down. But now I'm moving to the tens place, so I need a 0. 1 times 3 is 3. Now 10 times 8 is 80. And 10 times 100 is 1,000. So now I can add these all up, and I get a 6. And 9, 17. Why am I getting a wrong answer again? Or something's not right. Let me go back and look. Can you find it? 6, 160, 200, 30. Oh, now I know what it is. So I'm just going to restart it over here, and I'll show you what I did wrong as I'm doing it. And you know what? Since I'm doing this error analysis, I'm not going to forget it next time. Let me extend the page. Okay, so 3 times 2 is 6. 2 times 80 is 160. 2 times 100 is 200. 10 times 3 is 30. And right here, this is where I messed up. I did 10 times 8, but I should have done 10 times 80 because the 8 is in the tens place, or it has another number after it. So that would be 800. 10 times 80 is 800. 10 times 1,000 is 10,000, or 1,000. I'm sorry, 10 times 100. Gosh, I can't even talk. I'll tell you what, you guys are getting a lesson just like I'm in person today. 6. Oh, I need to extend the page. 6, 9. This is 10, 11, and 2. Finally, I got the right answer. So once again, my decimal goes after the 2 because I need 1, 2, 3 digits after the decimal in my answer because there's 3 digits after the decimal in the problem. Now, if you're good at the standard algorithm, we've already practiced this a few times. I'm putting the larger or the number with more digits on top. And here we go. 2 times 3 is 6. 2 times 8 is 16. Carry my 1. 2 times 1 plus 1 is 3. And 2 times 0 is 0. And then I'm moving on, so I need my 0. 1 times 3 is 3. 1 times 8 is 8. 1 times 1 is 1. And 1 times 0 is 0. And now I add them up. And I get 6, 9, 11, 2. I'm not going to lie, I was nervous I was doing it wrong the whole time. Okay, so the decimal, there's 3 digits after the decimal in the problem. There should be 3 digits after the decimal in the answer. So I get 2 and 196 thousandths, no matter which math multiplication strategy I'm using. All right, I got one more, and this time my goal is to not mess up. All right, here we go. We've got 14 thousandths times 16. So when I'm thinking about the area model, I can ignore the zeros in front of here and just think about the 14 because those are the digits I need to multiply by. I know this is going to give me 0. So I'm thinking it really only has 2 digits I'm using. So I'm going to split it in 2 pieces. And then 16 also only has 2. And I'm going to ignore the decimal and act like it's just a 14. So I'm going to put a 10 here and a 4 here. And then for 16, I'm putting a 10 and a 6. So it's 10 times 10 is 100. So far, so good. 4 times 10 is 40. 10 times 6 is 60. And 6 times 4 is 24. Now I'm going to add them up. 100 plus 40 plus 60 plus 24 equals 4. 12. 224. But I need to go up to my problem. How many digits is after the decimal in the problem? This time, when I'm looking at 0 and 14 thousandths, I have to count this 0 because it is in the 10th place and there's numbers after it. So I have 1, 2, 3 digits. That means I need 1, 2, 3 digits. That means my decimal is going in the very front. And then I could put a 0 here just to show that there is no ones. And my answer is just 224 thousandths. So that's what it looks like with the area model. Here we'll do the partial product. Again, I am going to ignore the zeros, and I'm just going to use the number 14. So 14 times 16. So 6 times 4 is 24. And then, oh, wait, partial product means I write it all down. 24, sorry. There, I did it. I messed up. So 6 times 4 is 24. 6 times 10 is 60. 10 times 4 is 40. 10 times 10 is 100. And I'm adding them up, and I get 4, 12, 2. Look, I got the exact same answer. 1, 2, 3 digits, 1, 2, 3 digits, put in my 0, same answer. All right, I'm going to put the standard algorithm over here so I have some room. Once again, I've got 0 and 14 hundredths times 16. So 6 times 4 is 24. Carry my 2. 6 times 1 plus 2 is 8. And then I know these are going to be zeros. Don't forget my 0 because I'm in the tens. 1 times 4 is 4. 1 times 1 is 1. And when I add those up, I get 4. I need to extend it. Here we go. I get 4, 12, 2. And 3 digits after my decimal in my answer because there was 3 digits after the decimal in the problem. All right, so guys, that's really the key to remember when you're multiplying decimals. However many digits are after the decimal in the problem is how many digits will be after the decimal in the answer. If you can remember that, then you're on a good start here. Now, the other key is that the whole multiplication. So I showed you 3 different strategies you can use. I know majority of 6th graders use standard algorithm, but I also know a lot of 6th graders who use the area model. So if this is something you really liked using last year or the year before, you can use it. Just remember the key is you have to put your decimal in your answer. And however many places are after, or how many digits are after the decimal in the problem, is how many digits will be after the decimal in your answer. All right, attached to this assignment, you will find something that you need to complete for me. Go ahead and give it a try and do any other assignments that are also on your Google Classroom Math page. And please feel free to comment or ask me a question directly through email or a private message, however you need to. But let me know if something isn't working for you and you need some help. All right? Get those multiplication charts out to help you, not calculators. All right, see you soon.